So these are called special products, or the difference of squares. So it's basically if you identify that it's a difference of squares, you can basically cheat and when you're multiplying these out. So you can do the distributive property, but what I do is I recognize that this is a plus 5 and a minus 5. So this is simply going to be a squared minus a squared minus 25, because a times a gives us a squared, and 5 times negative 5 gives us 25. If you were to expand this, you would end up getting a squared minus 5a plus 5a. So the 5a minus 5a is essentially 0, and it's eliminated. So it's basically you can do it like that. You can again you can expand using multiplication and end up with the same result. And I'll show you what I mean by that right now. So if someone else did it this way and they didn't recognize that it was a shortcut, and they said, okay, I'm going to do it with distributive property, would have a multiplied by a minus 5 plus 5 multiplied by a minus 5. Then you would expand it. A times a is a squared. A times a is a squared. And a times minus 5 is negative 5a. Okay. 5 times a is 5a, and 5 times negative 5 is negative 25. And collect like terms, and negative 5a plus 5a is eliminated, and you end up with a squared minus 25. So it's the same thing. One is you didn't recognize that it was a difference of squares for the special product, and that's fine. So I don't need these brackets. So either way, again, you get to the same result, so it doesn't make a difference. But again, to be the difference of squares, you just have to have the same a, the same b, and one is plus, one is minus, right? And it's as simple as that. Now, if this was 7x plus y multiplied by 7x plus y, then it wouldn't work that way. Then you have to do the specialty polynomial, which is the perfect square trinomial. And then you could do it that way. You could do 7x times 7x is 49x squared. So let's we can do the same thing here. So it's going to be equals 7x times 7x is going to be 49 x squared. Y times y is going to be y squared, and then the negative in between. Again, this will only work when it's a plus minus and the a and b term is the same. Okay, you could do this using distributive property, and the same thing will work like we did earlier on in some of the earlier chapters. Okay, or earlier sections in this chapter. So 10 times 10 is 100. It's minus, and then 4 times 4 is 16. 4 times 4 is 16. J squared. 16j squared. Right? Same deal with this. Even though it's k squared, it doesn't matter as long as they're the exact same, which they are. So that's going to be equal to k squared times k squared is k to the power of 4. K to the power of 4 and minus 1, because negative 1 times 1 is... this one here, a little more to it, but we just do the first two together, then we'll multiply that, and what we end up with is going to be a times a. So we're going to do the first two terms first, and then we'll see what we end up with, and you're probably going to guess what's going to happen, and that's fine. It's good to make those observations. So we have a squared minus 25. That was the first two binomials multiplied together. And then we'll rewrite the third binomial, which is a squared plus 25. And then you'll recognize, oh, okay, we have the difference of squares again, so we can do that. That is going to be a specialty multiple. We can do that. And we'll end up with equals, and a times a would be a to the power of 4, and 25 times 25 would be 625, and there we are, a squared minus 6 1/4, which is pretty neat. So it can be done twice in a row. So that's actually it for chapter 3. In class, I'll give you some work that we can do regarding this, but this is the homework for 3.8. Hope you're enjoying the videos. They're just another resource if you miss time in class, whatever the case may be. So thank you, everybody, and we'll see you in chapter 4 when we're looking at roots and powers. Thanks, everybody. Bye-bye.